Okay, so the first one for number 4, we'll be graphing that one on Desmos. This one would be a little tricky with getting the points to show up. So we've got y equals negative x plus 5 minus 1. And then do you guys remember how to get the points to show up on Desmos? Yeah, so click the table. Now, at this point, we got a couple points, but not very many. And if I go over here and press these, like none of these are the points that I need, like they're down there. So how do I get more of these points over here? Okay, so by the -2, this is where I'm going to click. The spaces are going to be empty. And I'm just going to go in and type -2, -3, and you can see the new points are being created. -5, -6. So this is the part I don't like the ones that are on the negative side because I have to do it myself. But once I type the numbers in, it'll just make them for me. So I would have graphed the vertex and then maybe like 2 points on each side is probably enough. So -5, -1 is the vertex. And then -6, -2, -7, -3, -4, -2, -3, -3. So there I've got all my points. So with that, your graph should look like this. We just had to get some extra points that weren't as easy to get. Okay. Was that better? That was the tricky part. Okay. All right. The next one, we're going to do the function 2 times the absolute value of x plus 1 minus 3. I'm going to type this in because we will need it. -3. Okay. So let's go ahead and start answering the questions on this one. So first it says, what are the transformations? What are they? Vertical stretch of 2. Vertical stretch of 2, left 1, and down 3. Okay. What are the x-intercepts? I'm going to get those from the graph on Desmos. So I can see the x-intercepts are -2.5 and 0.5. So I'm just going to write those down like the whole point, -2.5 comma 0 and 0.5 comma 0. So I wrote down the whole thing. Let me show you. There we go. -2.50 and 0.50. And then what is the range? So the graph went up like this. So I'm going to look at the point that's at the bottom. And since it's the range, I'm using the y coordinate. So I'll look at the bottom. The y coordinate at the bottom is -3. So I'm going to use the -3 at the bottom. And then the top is arrows going up. And so that's infinity. So my range is from the bottom to the top. So -3 to infinity. Infinity always gets a parenthesis. And then for the -3, the range describes just what y values I actually have. And since I can put my finger on -3, it's a y value that's actually there. So it gets a bracket. For the increasing interval, that is going to be where my little stick figure dude is walking uphill. So if he goes for a walk, this part is downhill, so I'm going to ignore that. But starting right here, he starts to go uphill. So this would be increasing. And I just want to label this value right here and this value over here. And so this is a right arrow, and a right arrow is a positive infinity. And then right here, I want to use the x coordinate for right there. And the x coordinate right there was a -1. So I'm going to write -1 for that spot. And so the increasing interval is from -1 to infinity. Infinity, again, always gets a parenthesis. The -1 is not going to get a bracket this time because when the stick figure is standing right there, he is not actively walking uphill. He's kind of in between uphill and downhill. So I'm going to put a parenthesis for that one. Okay. Is there any part of that I should explain again? Anything that didn't make sense? Nope, we're good. Okay. We're going to switch over to our notes. So go ahead and put your warm-ups away. We're going to switch over to the notes. So go ahead and do that. Get your notes out. And at this point, I shouldn't see any earbuds. I shouldn't see any cell phones. Chromebooks should be out. Your notes should be out, but everything else should be put away. We're going to need Desmos. Yep, we're going to need Desmos right now. So earbuds out. It's pretty good. It's pretty good. So in the past unit, we've been studying absolute value graphs. Those are perfect V-shaped graphs. And now we're going to move on to quadratics. Quadratic functions. And as we look at the quadratic functions, you're going to go like, oh, these are almost the same thing. And that's going to be nice because then the stuff we learned last unit is going to translate really well to this unit. So we're going to go ahead and graph this in Desmos, y equals x squared. So let's go ahead and do that. I'm going to pull up Desmos, y equals x squared. And then to do an exponent, you can do Shift 6 to get that little up arrow to go into the exponent spot, Shift 6. That puts you in the exponent, and then you can put a 2. Or you can do y equals x and then hit the keyboard down here and hit the a squared button. You can do x squared that way. So I prefer doing Shift 6. That's what I like to do, but it's up to you. So y equals x, and then you can hit this to get the squared. Or you can do Shift 6 to bump your cursor into the up position and then put a 2. All right, everyone got the x squared in there? X squared. All right, so I need to get my points so I can fill in the table on my notes. So I'm going to hit the gear, turn the table on. The table wants us to get x values from -3 to +3. So I'm going to make this table just a little bit bigger. -2, -3. There we go. And then we're going to write these values down. So -3 gives you 9. And if you want, we can kind of pull this down so we can see all the points. There we go. -3 gives you 9. And I'm just filling in the paper as I go. So -3 gives you 9, -2 gives you 4. -1 is 1. 0 is 0. 1 is 1. So I'm just pulling these values straight off of Desmos. Stay. Well, I guess these don't want to stay. Nope. Maybe? Huh. Huh. There we go. Okay. So we got 1, 1, 2, 4, and 3, 9. And you can see this graph is a nice U shape. It's definitely not a V. The last unit had V-shaped graphs. So we want to make sure that when we trace this graph, and connect these points that we make it look like a U and not a V. So make that graph nice and U-shaped. Mm-hmm. And we're going to do the transformations with these just like we did last unit with absolute value, and the transformations work exactly the same. So if you had a 2 in front of the equation, that would still be a vertical stretch. If you had a negative in front of the equation, that would still mean reflect over the x-axis. If you had a 1/3 in front of the equation, that would still mean vertical compression. If inside the equation you had a +1, that would still mean it moved to the left 1. So the transformations that you guys memorized last unit, those are still the same. So we already have kind of, we're already a little bit ahead on this unit because we've already learned part of it. We just get to apply it to something that looks slightly different, but not a lot different. Instead of having the vertical lines to show us what is inside, we're gonna have parentheses. So it's gonna look a little different, but it works the same. So over here, in this little section of our notes, we're gonna write down the transformations. So we're gonna say, if A is negative, that means reflect over X. Reflect over X. If A is greater than 1, that's a vertical stretch. If A is less than 1, that's a vertical compression. And over here off to the side, I'm going to say this is positive or negative. It doesn't matter if it's positive or negative. We're talking about the size of the number. If this is a 2 or a 3 or a -4 or a -3/2, if the size of the number is bigger than 1, that makes it a stretch. Now this could be a positive or a negative that's a smaller than 1. It could be a -1/3, and then it would be a compression. And if you would rather write that, then you can write it differently to make it make sense. So it's just like last unit. The negative makes it reflect over the x-axis. To make it a vertical stretch or a compression, it doesn't matter if it's positive or negative. It only matters what size the number is. So if it's a -1/3, it's a vertical compression. If it's a positive 1/3, it's a vertical compression. The negative only makes a difference for the reflect over x. Okay, next we go to the inside of the function. If it's a positive h, then it moved to the left. If it's a negative h, then it moved to the right. A positive h moved to the left. A negative h moved to the right. That's for the inside. And then for the outside, a positive k goes up. A negative k goes down. Say it again? I did not. Yeah. Now, don't judge me. It's because I don't have television channels. Otherwise, I would have watched it. But I live in a townhouse and I heard my neighbor yelling through the wall. So I knew when exciting things were happening. Thank you. Okay. So if we look at example 1, what are the transformations for example 1? What are the transformations for example 1? Right 2, right 2, up 3, and what was the first one? Vertical stretch. So just like we've been doing, right? The transformations aren't any different than what we've done before. Quentin, do I need to check your phone out the window, or are you ready to put it away, take some notes? Marvelous. Uh-huh. All right. So we've got the transformations, and then can somebody tell me what the vertex is? 2, 3. Okay, so we've got the transformations, we've got the vertex, now we just have to graph it. So let's go ahead and let's plug this into Desmos. So 2 x minus 2 squared two x minus 2 squared plus 3. Okay. You can put the y equals or not put it. Desmos is okay with it either way. So see how putting the y in didn't really change it. It didn't change anything at all. So Desmos is fine either way. So I'll press the gear. Okay. So Desmos gave me a couple points, but I want some more. So I'm gonna have Desmos give me a couple more there. Looks like these ones up here are too big for my graph, so I'm not going to graph those, but I can graph these down here. So 2, 3 is the vertex right in the middle. And if you guys remember, the easiest way to always graph these and to know that you're going to have enough points is to look for the vertex on the table. And then just make sure you have points on either side of the vertex. So the vertex on the table is right here, 2, 3, and then go on one side, so 1, 5, and then go to the other side, 3, 5. So 1, 5, and 3, 5. And if you can do 2 points on either side of the vertex, that is preferable. But sometimes the points just get too big too fast. So this one's 0, 11, and 4, 11. That's a little bit off the grid. We could still graph it, to be honest. It's not too far off the grid. So I did 2, 3, 1, 5, 3, 5, and then 0, 11. See, it's not too far off the grid, just a little bit. And then I'm going to make sure this looks like a nice U shape. Drew off the points a little bit. Yeah, try as much as you can, try not to make it look like a V, because we know a V is a different type of equation, right? That's the one we just studied. So we have to make sure this does not look like the one we just studied. Okay, there's our graph. Let's try the next one. So what transformations does this one have? Okay. Reflect over left 4, down 5. Okay. And then we also want to write the vertex down. What's the vertex? -4, -4, -5. Okay, so I for sure know that I'm going to have the point left 4, down 5. Now, this graph, it has an inequality, which means that I'm going to shade it eventually. And what I found is that Desmos will not give you points and shading at the same time. So we have to do the points first. And then once we're done graphing the points, then we can let Desmos help us with the shading. So I do know that at some point I'm going to have to plug this inequality in to kind of see where Desmos wants me to shade. Okay, so left 4, down 5. Is my line going to be a dotted line or a solid line? It's going to be a solid line. So based on this, we're going to have a solid line. Okay. All right, so let's go ahead and get this plugged into Desmos. So negative x plus 4 squared minus 5. There it is. It's all the way down here. Okay. It's not really showing us -4, -5. Okay. So let's get some of the points shown if we can. Okay, there's one over here. I need some more points over here. So I'm going to have to make my table. See, that's just way too negative. I'm going to have to make my table show some more negative values because my goal whenever I graph these is always to find the vertex on the table and then to get a point or two on either side of the vertex. And if my vertex is at -4, -5, that's not even on the table yet. So I'm just going to make my table have more spaces for negative numbers. And then I'm going to start plugging in these negative numbers. So here's the vertex. I just typed in the vertex. Oops. Ah. Okay, so I got the vertex. I've got 1 point on either side I can graph. Looks like maybe 2 points on either side I can graph. Okay, so -4, -5, -3, -6, -5, -6, -2, -9, -6, -9. Okay, there we go. We already said it was a solid line. Okay. So now let's go back and let's change that symbol from an equal sign to the inequality symbol to see where our shading should be. So I can delete the points because I don't need those. Y equals, okay, so I'm going to take my equal sign out. I'm going to type in less than, and then I'm going to put my equal sign, less than or equal to. So there's my solid line, and I already knew that. And then the shading should be inside the parabola. Parabola is the special math term for a U shape. Parabola. What's the origin? I have no idea. Feel free to Google that for us. Okay, so here's what we got. Looks like this. How you guys feeling? Meh. Does it feel a little bit like last unit? Yeah. Yeah? Okay. All right, flip the page over. All right, with this one, what are the transformations? Okay. Okay. And then do we have a vertex? And what is it? Yeah, vertex is -1, -7. So left 1, down 7. Okay. And so I'm going to go ahead and get this typed into Desmos and try to find my other points. Oh, gotta actually pull up Desmos. -1, -7. So 1/2 x plus 1 squared minus 7. Okay, so there's the graph. And let's get the table. So we have quite a few values in there. Let's get some more values over here. Oh, -4. That's probably good enough. So I got the vertex. I've got 2 points on other side of the vertex. If you don't want to graph the half points, we could ignore these. Oh, And then graph, yep, there's a whole number. We could graph that instead. Could avoid the half points. I bet there's another whole number on the other side. 3? Yeah. So we could do this one, and then these two, and then these two. We could graph it like that. And then you could avoid doing halves. So -1, -7, 1, -5, -3, -5, and then 3, 1, and -5, 1. So it's up to you. Whenever you guys see points that have decimals in them, if you want to avoid the decimals, you're certainly welcome to. Or if you don't care about decimals, then you could graph those. It's just up to you. So I didn't graph the decimals. Okay. So this is all we're doing on today's assignment is we are practicing graphing the quadratics and we're finding transformations and a vertex. So today should be easy peasy because you guys have done lots and lots and lots of this just in a different unit. Sound good? We feel like we can handle today's work? Maybe. All right, let me go ahead and hand it out.